Not that I can tell you without getting myself in trouble. I signed a confidentiality once, but I mean, pattern interlayers are important. So we'll start a new topic briefly. Tomorrow, you're going to see what is actually a very good video from 1980. It's called What Happens in High Energy Density Beam Welding Cutting. And we're going to start talking about fusion welding now. And you've got a copy of this in your handout, but we're going to look at the heat intensity on a surface in watts per square centimeter from 1,000 watts per square centimeter to 1,000,000 watts per square centimeter. And on Friday, I'll explain why that's important. But let me explain a little bit about this video tomorrow. It won the prize as the best film at the 1980 International Institute of Welding show. You don't attend those? Okay. But in fact, it probably should win the best welding video for the whole last century. Actually, I hadn't thought that was so funny, but in any case, I mean, it's sort of an honor for them. But anyway, the Japanese put this together at Osaka University, and it's narrated in a nice British accent. The Japanese like British accents. But it is an excellent video. They do things with lasers and electron beam so you can see the fluid flow that's going on. In laser and electron beam, you get a very deep weld pool. You have something on the order of 1,000,000 watts per square centimeter, and you will get, in cross-section, looking at the finished weld, you can get something that's 5 or 10 times as deep as it is wide. Okay, an aspect ratio, so the weld bead looks something like this. And it does that looking on sideways view. This is your weld metal that's solidified down here. This is the material you're traveling in that direction. And you actually, the beam actually drills a hole in the material. And you have fluid flow that sweeps around. So you're melting the front wall as you're moving forward with the beam. And the fluid flows around and solidifies in the back. Well, as it does that, it creates certain types of defects if you're not careful back here, depending on the fluid flow. I like to liken it to a motorboat going through the water. If you've ever done water skiing and stuff, you know as you go faster and the boat starts plowing through the water, you get a wake in the back of the boat where you have depressions and you have humps. Well, you're going to see the same types of humps in the electron beam welds, and they'll show you those, okay? In addition, so you can see what happens in laser welding, which is a similar process, and they take high-speed movies, they laser weld on Pyrex glass. So you just look right through the glass and you see the molten zone. You can see the fluid flow. So you probably haven't, I mean, now this movie actually, even though it was maybe a small community that looked at it, this movie has got some interesting things that even people who aren't interested in welding might be interested in. And in the electron beam, what they do is they weld on aluminum with an electron beam, and they use the X-rays that are generated by this 100 kilovolt electron beam that go through the aluminum, and they basically take an X-ray, a high-speed X-ray picture. And so you'll see, you have to look carefully, you're going to have to close the shades. Actually, you'll just see kind of a lot of gray, but you'll see a slightly different color gray in the beam hole region, and you'll see the thing, the beam bouncing around, and the bouncing around of the beam relates to some of the defects. One thing they don't explain in the movie is every now and then you'll see a little black dot right in front of this thing, and it welds over the black dot. And when it welds over the black dot, you see black swirl inside the aluminum. That is a piece of copper. They drilled a hole and put a little copper wire in there, and they weld over the copper wire. Copper, being more X-ray dense than the aluminum, shows up black on the X-ray image. And when you melt the copper with the aluminum, it mixes with the aluminum, and you can see the swirling pattern so as the copper mixes in on the aluminum. So you need to, they don't tell you to look for that, but that's what they're doing. But that's, I think it's better than my lectures anyway, to watch that movie. But, you know, so that